Rahim. Assalamu alaikum, dear students. This is our next problem, having been once again chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. In the Davisson-Germer experiment, using a nickel crystal, a second order beam is observed at an angle of 55 degree. Dear students, second order means n equal to 2. Okay. At an angle of 55 degree. For what accelerating voltage does this occur? We have to find out voltage. Okay, for this purpose we must have some background about Davisson-Germer experiment. Let us first come to helping tools, then we will explain. Okay, first tool has been taken many times, okay, in which momentum of a photon is defined. Okay, momentum of a photon P is equal to photon energy E divided by speed of light in vacuum C. Okay, this alternatively becomes equal to hf over C, where h is Planck's constant and f is the frequency. This alternatively becomes equal to h over lambda, where h is Planck's constant and lambda is the wavelength. Okay, we have defined this term several times, but despite several times repetition, whenever a tool is used or utilized in some problem, it will be repeated for newcomers. Okay, even equally beneficial for old users. Okay, now we come to tool number 2. This table has also been taken or chosen several times, but whenever this table is applicable to our concerned problem, it will be included in the tools. Okay, irrespective of whether we use tools thousands times, these will be repeated. Okay, our toolkit must be complete before solving any problem. Okay, so this there is nothing to be explained again and again. Okay, it is enough if this tool is shown in this video, in this problem, on the screen. Okay, here we will use this value. Okay, electron 0.511 million electron volt or 511,000 electron volt. Okay, in place of mc square. Tool number 3, relationship between electric potential energy and potential, that is delta U equal to Q delta V. Dear students, delta is usually denoted delta is usually used to denote change. Okay, so here delta U may be taken as equal to U2 minus U1. Similarly, delta V may be regarded as V2 minus V1. Okay, now we come to tool number 4. This table has also been repeated many times, but whenever it is applicable, it will be repeated in order to keep our toolkit complete. Okay, Dear students, here speed of light c equal to 2.998 into 10 to power 8 meter per second. This value will be used. Moreover, value of Planck's constant, which has been given in two different system of units, its second alternate value will be used in this problem. Okay. Moreover, combined value of HC is also given. Okay, but it is our discretion whether we take combined value of HC or we take separate values of H and C and then multiply them. Okay, so now I think we should move forward. Okay, now we come toward its solution. Dear students, our solution mostly it depends on this expression. Okay, d sine phi equal to n lambda, where n is equal to 1 2 3. Okay, this is the expression. We can take only this expression, but it is more beneficial if we describe something more about this expression so that a valid base may be developed for proper understanding of this expression. Okay, so dear students, the wording which I have used before writing this expression has been chosen from the same book which we are following, that is Modern Physics by Kenneth S. Crane. Okay, this wording is used in the book Modern Physics by Kenneth S. Crane regarding this expression, which is basis of solution of this problem. Okay, this expression says we know that maxima for diffraction grating occur at angles phi such that the path difference between adjacent rays d sine phi is equal to a whole number of wavelengths. D sine phi is equal to n lambda, where n is equal to 1 2 3 and so on. This is equation number 1. Okay, where n is the order number of the maximum. Dear students, here we will use n equal to 2 because in this statement it is given that second order beam. Okay, second order means n equal to 2. Okay, so this wording should be assumed sufficient to develop a basis or foundation for this expression instead of quoting this expression directly, simply without any explanation in wording. Okay, from independent data it is known that the spacing between rows of atoms in a nickel crystal is 0.215 nanometer. So according to this expression, this spacing will take the place of d sine phi equal to n lambda. Okay, so this is d. This wording has also been chosen from the same book Modern Physics by Kenneth S. Crane. Dear students, there may be some table in some book of physics where various such values are consolidated regarding different metals, elements, substances, etc. Okay, but I have failed in finding that table. Okay, so that is why I have explained that I have chosen this wording, this complete wording which we have so far described. This wording has been chosen or selected from the book Modern Physics by Kenneth S. Crane. Okay, D equal to 0.215 nanometer. What I have said that certainly some table may exist in some book of physics in which this value for various elements or metals may be given, but till now it is not within my knowledge. Okay, so I have taken help from this book, that is Modern Physics by Kenneth S. Crane, and from this book I have found this value, that is D equal to 0.215 nanometer. If this problem is given is asked from me as an assignment in which in place of nickel some other element is used, then I may be perhaps unable to solve that problem, because for that other element I shall do not have value of D. Okay, because I am unaware of the table in which a set of various values of this nature are given. Okay, however, in our subsequent videos, subsequent problems, if I find such a table, then I shall introduce that table as a tool in my problem or in my video. Okay, so dear students, using n equal to 2, because it is described in the problem that second order beam, okay, order of beam has been described as a second, so n is equal to 2, phi is equal to 55 degree. Okay, this is also given in the statement. Okay, 55 degree, and D is equal to 0.215 nanometer, which is a very rare value for me, about which I do not know enough. Okay, and I have taken this value from the same book in which book this problem is contained. Okay, so using these values in equation number 1, we get 0.215 nanometer into, that is multiplied by sine 55 degree, equal to 2 lambda, because n is equal to 2, second order beam. Okay, this implies that lambda becomes equal to 0.215 nanometer into sine 55 degree divided by 2. Dear students, value of sine 55 degree is 0.82. Okay, in lower classes I do not remember which method did we use to find the value of this sine 55. Definitely we used a scientific calculator, mostly fx82, etc. Okay, from that calculator we used to find out value of this nature of sine degree. Okay, but here, because internet is available, so I have chosen this value, that is value of sine 55 degree equal to 0.82 from internet. Okay, so no matter whether we take this value from scientific calculator or we take this value from table in hard form given in some book, or whether we take it from internet, okay, this is not an issue. Okay, so when we will simplify this, we will get value of wavelength lambda equal to 0.08815 nanometer. Okay, so one part of our problem has been solved successfully. Okay, now we come towards tool number 1, in which definition of momentum of photon is given. Okay, so using that tool, regarding definition of momentum of photon, we develop a foundation to reshape this expression so that we may find the value of P or value of PC. Okay, almost similar concept, whether we find the value of P or PC. Okay, so now also P is equal to E over C. This alternatively becomes equal to HF over C. This alternatively becomes equal to H over lambda, because we know that frequency and wavelength are inversely related, inversely proportional with the involvement of speed of light c. Okay, so F is equal to C over lambda and lambda is equal to C over F. Okay, this implies that P is equal to H over lambda. Okay, this implies that P is equal to H over lambda. In place of H, we have used the value of Planck's constant given in the table which has been introduced as a tool in our toolkit. Okay, divided by lambda, the value which we have calculated above. Okay, which is still being shown at the top of this page, not page, page setting, because page is longer and some part of page is hidden from screen, and some part of this page is being shown on screen. Okay, so P becomes equal to this over this. Then we have make an arrangement just in order to facilitate us. Okay, in order to reach the desired solution. Okay, what arrangement we have made? We have made an arrangement that we have multiplied and divided this expression by C. The only difference is that in the denominator we have not used value of C. Okay, we have not touched C. But in the numerator we have used value of C, speed of light, in terms of meter per second. Okay, when we apply this arrangement, second will be cancelled with second, meter will be cancelled with meter, and our subsequent step will result in only electron volt over C. Okay, so this implies that P becomes equal to 140.746 into 10 to power 2 electron volt over C. Dear students, here actually 10 to power minus 9 will be shifted on a numerator and it will become 10 to power plus 9. Okay, 10 to power plus 9 and 10 to power plus 8 will become 10 to power plus 17. Okay, on one side there is 10 to power plus 17 and on the other hand there is 10 to power minus 15. So resultantly 10 to power plus 2 will prevail, will overcome. Okay, 10 to minus 15 will be removed, and from 10 to power plus 17 only 10 to power 2, that is 100, will overcome, predominate. Okay, so P becomes equal to 140.746 into 10 to power 2 electron volt over C. When we eliminate or remove 10 to power 2, that is 100, then this decimal will be shifted 2 steps ahead. That is, in place of 140, it will become 14,074.6 electron volt over C. Now we move forward. Okay, now dear students, we know that in classical expression kinetic energy is given by half mv square and momentum is given as mass into velocity. When we solve these two equations simultaneously, then we develop a new expression, that is k equal to kinetic energy equal to p square over 2m. Okay, P we have found in our previous proceeding, previous step. Okay, so we have done here nothing. Simply we have used the value of P which we have found or calculated in our previous step. Oh, okay. So K has become equal to 14,074.6 electron volt over C whole square divided by 2m. This implies that K becomes equal to 198094365.16 electron volt square divided by 2mc square, because in the denominator c square is in the lower part of the denominator and it may be written as upper part of the denominator. Okay, c square in the denominator is written as a lower part of a numerator, so it can be shifted to upper part of the denominator. Okay, so k has become equal to this divided by 2mc square. Yes. Dear students, in the next step, what we have done, we have taken the value of mc square from a tool which we have introduced in this problem, in which value of mc square in case of electron has been shown as 0.511 million electron volt, or if we convert that million electron volt into electron volt, then it will become 511000 electron volt. Okay, so what we have done, we have replaced mc square by its equivalent value from the toolkit. Okay, so when we will simplify this, 1 electron volt will be cancelled with 1 electron volt and only simply electron volt will be left in the numerator. Okay, and hence our value k will become equal to 193.83 electron volt. Okay. Dear students, this desired kinetic energy, that is 193.83 electron volt, must be achieved. Okay, we have to achieve this kinetic energy in order to gain the desired potential. Okay, this desired kinetic energy, that is 193.83 electron volt, must be achieved, and for achieving this one, the electrons must be accelerated through a potential difference of delta V equal to plus 193.83 volt, as electric potential energy and potential are related by the expression delta U equal to Q delta V. Dear students, this expression, that is delta U equal to Q delta V, has also been shown in our toolkit. Okay, one of our tools deals with this expression. Okay, so we have just used a tool here. Okay, so this is actually the justification for describing that this will be the potential, this desired kinetic energy, that is K, that is 193.83 electron volt, must be achieved. Okay, we this kinetic energy is required in order that potential may rise to that level. Okay, this desired kinetic energy, that is 193.83 electron volt, must be achieved, and for achieving this kinetic energy, the electrons must be accelerated through a potential difference of delta V equal to plus 193.83 volt. What is the difference between this and this? The difference is that this is in electron volt and this is simply volt, as electric potential energy and potential are related by delta U equal to Q delta V, and for electron we use value of Q equal to small e. Okay, so when in place of Q we will use E, then this electron volt will be converted into simply volt. Okay, and this volt is potential. Okay, and this is the end of our problem. I hope you have understood it properly. Okay, till next problem, till next video. Allah Hafiz.